These examples are a little bit different. It's talking about constructing a probability model, which kind of looks like a table. And then it says determine whether the model is a uniform probability or a non-uniform probability. So we're going to do a couple together so that you can kind of understand what a model looks like. So example 1 says roll a 10-sided numbered polyhedron. So this is what a 10-sided polyhedron looks like. So basically it has the numbers 1 through 10. You might have seen it before. It's similar to a dice, but with 10 sides. So what are the outcomes? So if we roll that, what are the outcomes that we have? Well, you could get a number 1, you could roll a number 2, a number 3, a number 4, a number 5, 6, 7, 8, 9, or 10. Those are all of the outcomes. Now, probability, that just means what is the chance that you would, for example, land on a number 1. The probability that you're going to land on a 1. So again, you've probably seen that on the previous slide. It'd be written like this: probability of landing on a 1. Well, there's only one on the polyhedron, and our denominators always are total. How many total sides are on that? 10. So the probability of getting a 1 is 1/10. The probability of getting a 2 is also, there's only one number 2 out of 10. Probability of rolling a 3. There's only one number 3 out of 10. Probability of landing a 4. There's only one number 4 out of 10. So hopefully you're seeing the pattern that really it's all equal. They're all 1/10. There's no number that repeats. So there's not like 2 number 6s or 3 number 7s. It's all an equal chance for any number. So we'd continue and just write 1/10 for all of these. Now, because all of these are 1/10, so really there's an equally likelihood of getting any of the numbers, we call that a uniform probability. Because they all were 1/10 of a probability. So that's an example of a uniform probability in that first example. So example number 2 says randomly select a painted rock from a bag that contains 4 purple, 3 green, 3 orange, and 2 blue. So again, the first thing we need to do is write our outcomes. So what are the possible outcomes you can get when you pull a rock out of this bag? Well, you can get a purple. You can get a green. Do a little color coding here. You can get an orange. Or you can get a blue. So then we want to calculate the probability for each one of those. So the probability for a purple, is, well, if we go back up here, there were 4 purple rocks, 4 out of, so we want to count how many purple rocks there, or sorry, how many total rocks there are. So we have 4 purple, 3 green, 3 orange, and 2 blue. So again, we want to get our total number of rocks. So I know 4 plus 3 is 7, 7 plus 3 is 10, and 10 plus 2 is 12. So there's 12 total rocks. So the probability is 4/12. However, when we write probability, since it's a fraction, most times when we're writing anything in fractions, you'll always be asked to reduce or simplify the fraction. So I know I can divide both 4 and 12 by 4 to get a probability of 1/3. Okay, So that was the probability of a purple rock. So if we keep going with green, oh no, I didn't want to do that. Go back. Okay. Okay, probability of green is 3 green rocks. So if we take a look over here, 3 green out of our 12 total. Again, I can reduce 3/12 because I know I can divide both 3 and 12 by 3. So then I'll get 1/4. So the probability is 1/4 of pulling a green rock out of a bag. Orange. Orange, I had 3 orange, so that's actually going to be the same. Probability of orange is 3/12. Same thing, so I will get 1/4. And then the last one, 2 blue. So the probability of a blue would be 2/12. I know I can reduce 2/12 because those are both even numbers, so I know I can divide both at least by 2 to get 1/6 for my probability. Now, if I'm looking at all these probabilities, these are not the same. So this was totally different than our first problem where they were all 1/10. These are all different, so we're going to call this a non-uniform probability model. Which really means that the colors have different probabilities. So they're not all the same probability. They're different amounts of different colors of rocks. So that's an example of each different type. So you'll do 3, 4, and 5 on your own. Remember that you're writing the outcome, again, means, depends on the problem. And then the probability, you're calculating it and writing it as a fraction.